All right, this video is explaining question number 31 on the 3-3 assignment using the sum and difference identities to be able to solve. So we're going to do part A and part D. Before you get into using any of the formulas, you first have to figure out where these angles are located on your coordinate plane. So these are the clues that you've been given. For each of the angles, you're going to draw a picture for alpha. You're going to draw a separate picture for beta, and you're going to figure out where these angles are on the coordinate plane. So sometimes they're going to tell you specifically that in this case, alpha is greater than 0 and less than pi over 2. So they're telling us that it's in the first quadrant someplace. We don't know exactly where. I'm going to just draw it somewhere in the first quadrant. I'm going to take a point somewhere along that terminal side and make a little right triangle going down to my x-axis. They told me that sine of alpha is 3/5. Sine is y over r. So that tells me that my y value is 3 and my radius is 5. And so to find the missing side, I can use the Pythagorean theorem. This is a Pythagorean triple, and so it's 4. In this case, since we're in the first quadrant, everything is positive, so that makes it a little bit easier. When we look at beta, it tells us that beta is greater than negative pi over 2. So negative pi over 2 goes from the positive x-axis in a negative direction clockwise. This is negative pi over 2. It's equivalent to 3 pi over 2. So we know that beta is greater than negative pi over 2 and less than 0. So it tells us that it's somewhere in the fourth quadrant. This is my angle beta right there. I can draw a triangle from the terminal side up to the x-axis. This time they're telling me what cosine is. That's x over r. So my x is 2√5. My r is 5. I need to figure out what my y is. Before I actually figure that out, I'm going to notice that I'm in the fourth quadrant, and so I will know my y value is going to be negative. The most common mistake that people make with these is that they forget about the negative. So let's go ahead and use the Pythagorean theorem to solve this, to figure out what that y value is. It's not a triple, so it's not quite as easy as the other one. And I'm going to substitute in my x and my r. When I square 2√5, I'm going to square 2, which is 4. I'm going to square root 5, which is 5. And that's going to give me 20. And I'm just going to solve this equation. And I'm going to end up with y is equal to positive or negative root 5. I already determined that this has to be negative, so I know that this is negative root 5. Now that I have those different measurements, I can now going to be able to use them to put into my equation. So the question was asking us to figure out what sine of alpha plus beta would be. So if I added those two angles together, what would the sine of that new angle be? And so I'm going to use my identities formula sheet. I'm going to look at sine of alpha plus beta, which is right here. And I'm just going to rewrite the right-hand side of it, which looks like this. And then I'm going to go and find those values from my triangles. So sine of alpha is right here. They told us that initially it was 3/5. Cosine of beta, I'm going to go to the pink picture here, and cosine of beta also, they told me that to begin with, is 2√5 over 5. Plus cosine of alpha, here I'm going to do x over r, which is 4/5. Sine of beta is y over r, negative root 5 over 5. You'll notice that none of these are repeats. I have each of them are 4 distinct different ratios. Now I'm going to simplify this. My numerator here, I'm going to do 3 times 2 is 6. 5 times 5 is 25. Here I'm going to multiply my numerator. I'm going to get negative 4 root 5, and the denominator is 25. Since my denominator is the same, I can combine that into one fraction. And I can treat my root 5s as like terms. So I have 6 root 5 minus 4 root 5. It's going to equal 2 root 5 over 25. There's nothing more to simplify. I don't have to rationalize this since there's no radical in the denominator. So that is part A. Part B, we're going to use the same two triangles, but this time we're going to use a different identity. Since we're doing tangent, and we're doing tangent of alpha minus beta. So again, we're going to go to our identity sheet. We're going to find the one with alpha minus beta for tangent, and we're going to just go ahead and rewrite that identity. And then we're going to use our pictures that we made before to find the tangent of alpha and beta. So if I'm doing the tangent of alpha, the tangent of alpha is y over x, so that's 3/4. Minus the tangent of beta is y over x, it's negative √5 over 2 √5. We can simplify that a little bit, and it's just going to be equal to negative 1/2 divided by 1 plus 3/4. And I already figured out that this tangent of beta could be simplified to negative 1/2, so I'm going to just use that since I don't need all of those roots in there for this one. And now I need a common denominator. My common denominator here, I have a 2. I need to multiply by 2 over 2, so I get a denominator of 4. And you need to be careful here. You're going to have a 4 as your denominator, but you have a negative and a negative there. So you're going to have 3 minus negative 2, which is going to end up being positive 2. So that simplifies to be 5/4. I'm going to change this big division sign into, or big fraction bar into a division sign. And here I'm going to have 1 plus negative 3/8. Again, I need a common denominator here, so I can make that 1 into 8 over 8. I'm going to have 5/4 divided by 8 over 8 plus negative 3 over 8 is going to be 5 over 8. And I can now change this 5/4. I'm going to change this division into multiplication. Multiply by the reciprocal of that, which would be 8/5. The 5s can cancel, 4 can go into 8 twice. And so all of this simplifies to a nice, simple 2.